How's the volume? Good? Not too loud, not too quiet, just right? Okay, good. I'm Angela Metler. I'm an administrative assistant in the president's office at South Dakota Mines. And I would like to thank you all for coming tonight for STEAM Cafe. I'd also like to thank the people that are joining us on Zoom online. After the presentation, there will be a question and answer session. So we will answer those questions live, whether they're asked here in the crowd or whether they're asked on Zoom. So Zoom attendants, if you have any questions, please type them into the chat box or the Q&A so that we can answer them. STEAM Cafe is a partnership with Hay Camp Brewing and South Dakota Public Broadcasting, and we appreciate their support as well as your support. Tonight's presentation is from Dr. Trevor Waldien, who is an assistant professor in our Department of Geology and Geological Engineering. So I will turn it over to him.
Hi, everybody. Can you hear me okay? Wonderful. All right. So my name's Trevor, and I have a special skill called geologic mapping. Okay, and I say special skill because it's one of those things, as we all know from our certain disciplines, that used to be sort of commonplace, right? Everybody learned how to do this thing, and over time it's become either automated or has become in some way a specialization that only certain people tend to do for their career. Okay, so geologic mapping and the geosciences is one of those things. Okay, so I'm here today to basically share with you what it's like to be a geologic mapper, and I have a place that I like to go geologic mapping, which is the middle of absolute nowhere in Alaska. And I will show you some pictures of that. So I basically a three-part talk today. It's a little bit of education, a little bit of picture show, and a little bit of step-by-step instructions, a cookbook, if you will, for geologic mapping. Okay, so let's get started. This is a geologic map of North America. A lot of you have probably seen something like this before, some sort of geologic map. And basically what we're looking at here is a topographic base. So some layout, either contour lines or a hill shade, some shading, something like that, that tells you what the topography is. And then on top of that, we have all of the colors, and those represent different types of rocks. In geoscience, a lot of what we do depends on what the rocks are and where the rocks are. Okay, so with those two things, we can do all sorts of high-class analytical work, crazy, really numerically sophisticated stuff, but it really comes down to what are the rocks and where are the rocks. And a geologic map like this in North America tells us where the rocks are and what the rocks are. Okay, so it's a fundamental baseline for doing any sort of fancy, modern science, cool stuff, is really got to know what the rocks are and where the rocks are. Okay, so here's a geologic map of North America. We'll come back to this. Well, let's zoom in a little bit. I noticed before the presentation, this got a little bit washed out, but that's okay. This is a geologic map of the Nemo area here in the Black Hills. Okay, and I just want to point out a couple basic features of a geologic map. So here in the middle, you'll see that there's the map. Okay, and it's blurry for a reason I'll tell you about in just a second. Over on the right, we have the map legend. All these little boxes with colors and the paragraph next to them. The colors with some symbol inside tell you what the rock is. It tells you the age of the rock. And then the text right next to it tells you features of that rock. So is it sandy or is it a granite? Is it a schist, phyllite, any of that kind of stuff? Okay, so this is a basic description of these colored map units that you find on this map here. There's a bunch of lines on geologic maps. You can see all the lines here, those have descriptions with them as well. And then there's some other features down here at the bottom. We've got some cross sections, which are basically vertical slices through the map to show what the author of this map thinks that things look like with depth, a vertical slice through the map. And then a very important feature, which we'll talk about more in just a second, is this part right here, which is our scale. Okay, so you've probably seen a scale bar like this. It has, maybe 1 mile, half a mile, 0, and then 1 mile on the other side. You'll often find them in kilometers as well, right? We'll come back to scale. But if we take a zoom in on a geologic map, so I've zoomed in here to the northeast corner of the Nemo quadrangle, and this is a place that a lot of us really like in the Black Hills. This is Little Elk Creek. Okay, so you can access this trailhead from just up here on the freeway in Piedmont. You can also access it from Dalton Lake if you drive out to Nemo. All right, so this is just a little zoomed in snapshot of this geologic map. There's different colors on this map, which tell us the different rock types. And then we also see these lines here on this map. So these are contour lines, just like any contour map that we might get at a store in a national park, or you can just download these things off the U.S. Geological Survey's website. It's just a contour map that tells you what the topography is. So that's our topographic base in this case. All these squiggly lines around here are the topographic contours. And then overlaying on that are these different colors here, which tell you the different rock types. We've got a bunch of different symbols on this map. We've got some lines here with symbols on the lines. We've got little measurement symbols here. If you have questions about those, I'm more than happy to give you an entire semester worth of content on that in my structural geology class. But we won't talk about those right now. The main point is that if you were up here in Little Elk Creek and you were walking along the road and you wanted to take a little hike out here into the woods and you found yourself at that exact location on the topographic contour map and you look at your feet, you should be seeing WOS, which is just an abbreviation for whatever rock happens to be there. For this map, it's this thing called the Little Elk granite, okay? So each color tells you what rock is in that exact spot on the topographic map. That's how you read a geologic map. Next thing we'll talk about here is scale, okay? Like I said, you'll see a scale bar. It's got different measurements for how big a kilometer is or a mile or whatever. But you'll also see something that looks like this here, a ratio. Scale 1 to 24,000 or 1 to 250,000, 1 to 100,000, something like that. It's just a ratio. So what does it mean? What it means is 1 of something on the map is equal to 24,000 of that same thing in real life, okay? So 1 millimeter on the map, that distance of 1 millimeter on the map is 24,000 millimeters in real life. It's just a ratio. It's a ratio of how big your map is to how big real life is, okay? So let's do a little bit of math real quick, okay? A scale that I like to work with because it's easy is 1 to 10,000, all right? And I like to do things in metric because I'm progressive, all right? So 1 millimeter on the map is 10,000 millimeters in real life, and that's equivalent to 10 meters, okay? I'm about 2 meters, not quite 2 meters. All right, so 5 of me would be 1 millimeter on my map at 1 to 10,000. A lot of us use a 0.5 millimeter mechanical pencil, all right? So that means the diameter of your pencil lead in air quotes, is a 0.5 millimeter, okay? So a 0.5 millimeter on your map is 500 millimeters in real life, which is 5 meters in real life, all right? So 2.5 of me. So what that means when we are geologists out there mapping, and if we're mapping at 1 to 10,000 scale, we cannot resolve anything smaller than 5 millimeters because our pencil is too big, all right? So the way I like to explain this to my students is you're out there walking around, doing your thing, and then out of the sky comes a gigantic cylinder of graphite that has a 5-meter footprint on the earth, and it will squish you if you're in the wrong spot, right? So that's a way to think about it. So we as geologists, maybe we see an outcrop the size of this table or something like that. If this outcrop is not 5 meters across, we cannot get it on the map if we're mapping at 1 to 10,000 scale. So what are we going to do? Forget about it? Maybe. Or we come back at a higher resolution, maybe 1 to 1,000 or 1 to 500, then we can actually get that stuff on the map, okay? So this is the importance of map scale here, all right? And there's always this question, is it geologically reasonable? And of course, that depends on the geology. So this is a geologic map of Alaska, or at least a screenshot of the geologic map of Alaska, since most of the talk today is about Alaska. And all the mapping in Alaska, at least that's published, is at 1 to 250,000 scale, okay? So if we do our little math exercise that we just did, that means our 0.5 millimeter pencil lead is 125 meters. That's a football field. So your pencil coming out of the sky is now the size of a football field, all right? But that is the resolution that we have on the geologic map of Alaska. So for folks like me that like to make geologic maps, this is a great place to go and do better because the resolution is not very good. Not only that, we have issues like this thing here. Do you see that? That line going across the middle of the screen, that's not real. All right, that's not something recorded in the geology. What that tells you is that person A mapped this area and person B mapped this area, and they didn't talk to each other. All right, so we call these map boundary faults, because this is basically what a fault looks like on a geologic map, where it cuts across things. Whoops. Cuts across things. This is not a real fault. This is a communication breakdown between the people that mapped in this area before. So one of them is wrong, maybe both of them are wrong. But that's something, if we're going to have a good map of this area, that's something that we would need to fix, right? The other thing to pay attention to here is simply related to our map scale. This scale bar down here in the lower left is about 6 kilometers. Okay, so that length of that bar is 6 kilometers. So if you look at these map units and the size of some of these colored areas on this map, it's telling you that everywhere you see KFY, this kind of disgusting brownish green color here, is all the same rock type, or at least they've lumped it into being the same rock type for the purpose of this map. And that may be perfectly adequate for this particular map, but if there was a reason to know that in any more detail, this map is not adequate to resolve any finer resolution geology, because right now it's basically saying, well, that whole 15-kilometer swath through there is all the same rock type. It has the same unit description, even though there might be heterogeneity in there, it might be different, but that variability is not captured on this map, okay? So the state of mapping in a number of places and the resolution of mapping in a number of places has a great amount of opportunity for improvement, okay? So we come back here to our geologic map of North America. We have a geologic map of our entire continent. So I get asked, not uncommonly, why are we continuing to make geologic maps? We have a map. And the answer that I always give is, well, is the map adequate resolution to do what we need it to do? And how accurate is that map? I think just simply based on this image here and our map boundary fault, we could say that there is room for improvement as far as the accuracy goes in this particular map right here. Okay, and of course the resolution issue that I just talked about. Okay, plus another thing that I thought about actually when I was coming down here tonight is that our ability to survey the topography of the globe has improved dramatically in the last 30 years or so. You know, with all the satellites that we have now and LiDAR and all these types of things. And a lot of the maps that went into compiling this geologic map of North America are based off of 1950s, 1930s geologic survey topographic maps, right? So if we have a higher resolution image of the topography of the surface of the earth, we can get a higher resolution geologic map as well, okay? So as one thing gets better, the other can get better as well. So that's my pitch for why geologic mapping matters. And maybe you're asking yourself, okay, great. How does it actually work? Well, I've spent about the last 10 years wandering amok all over southern Alaska. I spent most of my time here in the Alaska Range, where I did my master's and PhD research. I've gone on various field trips and field excursions here in southern Alaska, and I've got a project going right now in western Alaska out here. I also thought on my way down here tonight, well, you know, it would have been nice to show the roadmap of Alaska here too. And I hear some people laughing at it. That's wonderful, because that's the joke. The roadmap of Alaska, basically, there's a road that goes up through here like that, and then there's a road that goes up through here like that, and then there's a road that goes over there. And that's the roadmap of Alaska, okay? So you notice a lot of these yellow circles here are not on the roadmap of Alaska, all right? So that makes some complications on how we actually get there, but it makes it really fun as well. So how does this actually work? Okay, well, so I've been a lower 48 dweller my entire life. So that means that when I want to go work in Alaska, I usually fly to Alaska. So we fly into Fairbanks, sometimes Anchorage, but usually Fairbanks for the stuff that I've been doing. And we spend a couple of days in town, and we buy anything that we didn't fly up with from lower 48. Okay, so in the case of Alaskan fieldwork, by and large, that is cans of beans. Okay, everything that we eat comes out of a can, or it is dried ahead of time. We don't have, you know, carrots are okay, they last a couple weeks. If the weather's cold, cheese lasts about a week. But other than that, we don't get fresh food. So we go to the store and we spend about, I'll just say several $100s, depending on how many people and how long we're out there, on canned food. And we just basically take the shelves and wipe it into the cart and then go to the cash register and they look at us like we're nuts. Okay. We take that food. We usually put it in buckets, but we also use bear canisters, and we've got all our camping gear there too. So we usually rent out a hotel that's one of those suites, and we just explode all of our stuff all over the place and then get it all organized into buckets and bags and whatnot. And then we take it to the pilot's headquarters. Okay, so this is usually how we would do field work. Sometimes we use helicopters. This particular year, we're using a Super Cub. We put all our stuff in dry bags. If you've ever been on a rafting trip, you put all your stuff in dry bags and you tie it to the boat in case the boat flips over, right? Well, we're not on, well, people actually do mapping by boat. I haven't done that personally, but we use the same gear because Alaska is a wet place. Okay, we'll talk more about that in a minute. All our food here in the buckets and the bear cans, and then a fire stick for safety. So then we fly over some really neat places to get to where we actually want to be and find someplace flat enough for the pilot to land. Okay, in this case, this particular field season, this was 2016, we found a nice gravel bar next to a creek, and pilot was able to land us there. You throw all your junk out on the ground. In this case, this was from this last summer where the helicopter pilot said, some of this stuff might fly away, so why don't you lay on it while I take off? So I said, okay. So they throw all your stuff out, they leave, and there's wait, maybe I can do it here. Okay, there it is, yeah. So they leave, there you go. I love these things. When they're empty, they don't have anything in there. They can take off in 50, 100 feet. They just, at I don't know how fast he was going, maybe 30 miles an hour, something like that. So these planes are really, really neat. They leave, and then you're there, and you just start thinking about all the things you probably forgot. But, you set up your tent, you throw your sample bags and your sleeping bag in there. And these are some of the coolest places I've ever camped. I would say 5-star lodging, but you already heard about our grocery shopping adventure. And one of the things that goes into that grocery shopping list is a whole lot of hot sauce. Because after 2 months, black beans don't taste so good by themselves. All right, so what does mapping actually look like? Well, we spent a lot of time walking. I don't think ever gone to the field and gotten heavier while I'm in the field. So we walk all over the place. You're looking at the rocks, trying to find what's going on with the rocks, what's the important stuff, where can I go to learn more? And then hopefully you find some place where you can figure out what the relationships are among the different types of rocks. Okay, so that would be a neat spot like this, which I've annotated in the way that we would map it as a geologist. So we've got some dark rocks up here that are basalts. That's a type of lava. Okay, we've got a fault that's carrying those lavas and some other types of rocks, and then they're placing them on top of some sedimentary rocks here that are layered, and we can show the orientation of the layering and the sedimentary rocks. So this is the type of stuff that we see through our geology goggles, and then we're putting that information down onto paper to make geologic maps. Okay, when we do that, we're also out there measuring things. So here a student of mine and myself are measuring some fracture orientations in the rocks, which tells us about the deformation history of the rocks. We also tend to grab some samples to either date the rocks or do some analytical work on them or make thin sections so that we can look at them in microscopes. And then we take all that information and put it together on our map from the field, and it looks something like this. So this is just a scanned image of one of my field maps. You can see the contour lines here, the topographic base. I've also got some shading that shows some topography in between the contour lines, and then there's a couple lines on this map which represent various geologic features. In this case, it's a lot of faults. Okay, you take all of those individual field maps, you compile them all together using some digital mapping software, and then you can make a map of a whole area that look something like this. So this is a figure from a paper that came out of my PhD, which was about 3 summers worth of mapping, where I took, I'm just going to say off the cuff, maybe 40 maps that look like this. stitch them all together to get something that looks like this that you can actually work with, publish it, make cross sections of this, you know, show where the rocks are, that you dated those samples, all that kind of stuff. And this is proper science. This is publication worthy science, right? And it all starts with getting in a plane and having a guy drop you off and then eating beans for a month. Okay, so when I was asked to do this talk, I was asked to primarily tell stories. So now we're going to shift into story time. Okay, and to tell my stories, I'll highlight something that a colleague of mine refers to as the bees. Okay, and the bees are primarily bears, bugs, and bushes. And then I've come up with some other things that are quite bothersome as well. All right, so let's talk about some bees here for a minute. We'll start out with this. I found this on a fishing guide website. This is Katmai Fishing Guides. They're out in King Salmon, Alaska. And this is just a chart that shows months of the year: April, June, July, August, September, October. Average temperature, rain, fish, and bears. Okay, so this, if you think the way I do, this makes it pretty obvious when you go to do field work, right? I have done field work in August. It's not optimal. September is a no-go. Almost all of my field seasons that have ever ended in August ended with a snowstorm and a phone call to the pilot that says something like, "Can you come get us?" And the answer is, "Not yet." And so we sit there in our tents, freezing our butts off, reading books until the pilot can come get us. So August and September don't work out so hot. April and May, usually the snow hasn't melted yet, so not great. The sweet spot is usually sort of late May through July, depending on what elevation we're working at, okay? And the reasons for that are primarily due to snow melt and rainfall, but also because of these guys here, right? So they start coming in, going at higher and higher elevation as the summer goes on. But they're looking for fish, right? So I've basically made a choice to just avoid anywhere that fish live, and I've done okay. I'm still here to tell the story. I was realizing as I was putting this presentation together that I don't have any pictures of bears, because when I see bears, I'm not reaching for my camera. But this last summer, we drove down to Canada to do a little bit of reconnaissance for a potential project in Canada, and we were on the road in a car driving. And there was a traffic jam up ahead, and we're like, "Oh, what's going on up there?" And a bunch of people had slowed down because there was this little black bear on the side of the road. So this is my only picture of a bear that I've taken. It's because I was inside of a car. But yeah, so, you know, someone asked me the other day how many bears I've seen, and I don't know. I would say 10-ish in the last 10 years, so one a year, I guess. And I'll tell you that any close bear encounter I've had is always when I'm downwind of the bear. If they can't smell you, you're in potentially a bad situation, right? So I've had situations where we're climbing up the side of a hill, and then the bear gets to the top of the hill the same time we do, right? And then so that becomes an awkward situation. And in all cases, you know, we just reach for the spray and start screaming your brains out. And usually if there's more than, you know, we always work in pairs, 2 or 3 people. There's some statistic out there that as you go from 2 people to 3 people, that when there are 3 people present, your bear encounter is significantly less likely to turn into a bear attack. So at least 2 people, 3 people is better. And when the bear starts hearing, you know, a whole crowd of people yelling at it, like, what would you do if a bunch of people were yelling at you? You get out of there, right? So that you know, has worked out pretty good so far. But yeah, bears got to be careful. Bears got to be careful. Lots of signs of bears. Pretty much every year we find some poor animal that wasn't quite fast enough to get away, or however it happened to work out. Maybe got injured ahead of time. This particular one was a sheep in 2018, and you know, this is probably the most intact part of that sheep that we could find. But always signs of bears: bear poop, footprints the size of much larger than your head, much larger than you want them to be, much fresher than you want them to be, all that kind of stuff. And then we also have some preventative measures as well. So this is a a picture of one of our camps this last summer, and I've zoomed in on this spot down here in the bottom, which is our camp. And the point I want to make right now is that we don't cook where we sleep, right? So all the food, everything that smells like anything but a human, you know, chapstick, sunscreen, toothpaste, you name it, goes in this tent, which is a very much farther than you want it to be a lot of times, but really far, as far as it can be within reason, away from your sleeping tent, right? So we sleep over here, and all the food, everything else goes over here. So if there is an incident, more often than not, the bears are not looking for people. They're looking for peanut butter, right? Or Cliff Bars or toothpaste or whatever. My PhD advisor has a story where her advisor had his tent ripped into by a bear, and the only thing that it rifled through everything, and the only thing that was torn up was his toothpaste. So, you know, it's good to have dental hygiene, but keep it in the kitchen, right? So so preventative measures are a big deal too. And we, you know, one of the preventative measures is not only, you know, bears, they smell us, they don't like that, right? But if they hear us, they also don't like that. They hear something weird, they'll get out of there. So we sing songs, tell stupid stories we've told 5 times already. You know, the person that's with you for a month or 2 out there gets to know you pretty well, and to the point where you sometimes are looking forward to that last day where you get to part ways, right? And you know their stories too well, they know your stories too well, and it's time to go home, right? But it's a good tactic to keep the bears away. But, you know, everyone always asks about the bears. Have you seen a bear? Like, yes, I've seen a bear. But there's loads of stuff I've seen that's not bears. Nobody ever asks about how many caribou I've seen, right? So here's caribou. This was a pretty big guy. And caribou, interestingly enough, I was really freaked out about this the first time I saw a caribou, but they're very curious. It just walked right up to me, like, you know, me to the curtain 20 feet away, just looking at me. It's like I was about to whip out my bear mace and mace this caribou because I didn't know about caribou, you know, like no deer or elk I've ever seen was going to do that. So I wasn't sure what was up with this caribou, but I've learned that caribou are just curious. They're not going to do anything weird. You know, I've seen porcupines and wolverines and bald eagles, peregrine falcons, wolves. Seen a couple of wolves up there. Actually, one time we were moving camp out of one valley, kind of a hanging valley with a glacier in it, down to another valley. And when we walked downstream, we were walking along the creek, dropped all of our stuff in our new camp. Then we're walking back to get the rest of our stuff. And when we were walking back, we saw wolf prints in the sand right next to our footprints. So our footprints were going downstream and the wolf footprints were going upstream into a dead end hanging valley. And we're like, well, we would have noticed that when we were walking through here the first time, right? It's like, yeah, we definitely would have. So we got our stuff as quickly as we could and got the heck out of there. But you know, it's just neat wildlife stuff. Nobody ever asks about anything but the bears, but there's all sorts of stuff. I've seen way too many marmots and ground squirrels. They always come to chew on your backpack and stuff in the middle of the night. And I could do without ground squirrels, but they're funny too. All right, so bugs. Bugs suck. This is a joke, obviously, but it's one of those jokes that's funny because it's like a little too real, you know. But the state bird of Alaska is the mosquito, right? And usually in the past, I haven't had too much problem with bugs because I've worked in the really high mountains, and I'll show you in a second, but there's a lot of wind, it's cold, the bugs don't like it up there. But sometimes you can't always get out of the high mountains and you gotta work down low. And when you work down low, there are mosquitoes everywhere. So these are some pictures from this last summer. These are my pants, and you can, I don't know, count them. When I pulled my phone out of my pocket to take a picture, a bunch of them left, and then some of them came back. So I got some on there, but it was one of those things where it's like, this is so absurd, I need to take a picture of it. And it turns out I had a reason to take a picture of it for today. But we, this last summer, asked the helicopter pilot to come back. So he dropped us off and then was going to come pick us up a couple days later. And our bug spray was getting kind of low, and we still had a couple weeks left. And I was like, well, it'd be best to not run out of bug spray. So we asked him to bring some more bug spray back with him, and he brought these like bug net things. I've seen the bug nets that go over your face, but I've never seen the ones that's like a shirt. You know, imagine a sweatshirt like with a hood, but it's just screen. And we saw those things and looked at, oh, we don't need these. This is so overkill, right? And then the clouds came in and the wind stopped and it warmed up a little bit. And guess what we needed? Right? So here it is. I'm wearing my bug net. There's one sitting right there trying to get me through my hat. There are a couple others on here too, but I didn't think it was that big of a deal. And then I was brutally informed this last summer that I probably do need a bug net. So I kept it. I didn't throw it away. I'll use it again next year. All right. So this is my PhD advisor, Sarah Ruskey. And she has been working in Alaska since, I think, 1980. And in 2014, we were in the field and there had just been a hatch of some little black fly, not mosquitoes, but as a fly. Okay. And usually for simplicity, but also for energy, we eat oatmeal a lot. You know, it's easy. Oatmeal's cheap. You can buy loads of it. It's amorphous. So you just put it in Ziplocs and stuff it in a bear can. It's easy. All right. And so we eat oatmeal a lot. And this one particular morning, this is early June, I believe. And we're working relatively low elevation that year. There had been this hatch of bugs, and I tried everything I could to keep them out of my oatmeal. And so I take a scoop of oatmeal, and from the journey from my bowl to my mouth, I was just like scooping up bugs into this sticky oatmeal, right? And I'm like, oh, this is gross. So I'm picking them out of there and stuff. And Sarah looks at me and she just says, there's no use in picking them out. So I just dealt with it. And so a little extra protein in the oatmeal that morning. Actually that was 2014. I've not had an experience like that since. So maybe that was a one-off, but it didn't seem like new territory to her. She just ate the oatmeal. No problems. So, you know, you can always learn things from your advisor. So avoiding bugs. This has historically been my approach to avoid bugs, which is to go nowhere that bugs want to go. Right. So this is top of a ridge between a couple of glaciers. Glaciers, you're cold, you know, the air is warm, so they make wind, and it's usually pretty windy up there. Clouds are moving in and out. It's cold. Bugs don't want to be there. But if it's not too windy and too cold, I'll be there happily. It's totally fine. So anyway, we actually went up here to grab a sample to date this particular rock, and I got a picture up here. This is actually on my 25th birthday. And a funny story about this day is, you know, we got up here, big mountain summit, and we got back down to camp, and I was like, you know what? It's my birthday. Let's make fish tacos, which in Alaska, fish tacos is canned tuna with some olive oil in a pan and lemon juice out of one of those lemon juice bottles that looks like a lemon, but isn't actually a lemon. And then a stale tortilla with a lot of hot sauce, right? So during and you know, if we're lucky, some rice, I guess, rice and beans. During our prep, we had somehow managed to spill some of the rice or something onto the tundra, which is, you know, the floor of our cook tent is just tundra, and it's rocks and vegetation and things like that. So we're, oh, well, we can't do that. So we scooped it back into the bowl. And so I'm eating my taco, and I take a bite and I munch down on a rock and get this awful pain in my mouth. And I went to the dentist when I got back, and I actually cracked a filling. So it wasn't bad enough to be evacuated for any reason like that. But anyway, I learned my lesson that when you spill something onto the tundra, just leave it. It's not worth the extra 30 calories to eat those 5 pieces of rice. Right. So let that be a lesson to you. It took me 25 years to learn that lesson, but maybe you already knew that. All right. So, you know, avoiding the bugs, not always possible. You probably heard this phrase, everything's bigger in Texas, right? And I actually saw a bumper sticker once that said, my state is bigger than yours. And it had a picture of Texas. And well, there's one example of a place where that's simply not true, at least in the US, right? And that's Alaska. It's actually the biggest state. And everything's bigger in Alaska. It has the biggest mountains and the biggest swamps. All right. So, as geologists, we usually want to be where the rocks are, which is where the mountains are. But sometimes to get to the mountains, you have to pass through all the big swamps. All right. And there's these big lakes out in here, right? Just perfect nesting grounds for mosquitoes. So you can't always avoid the bugs. Which brings me to my next B, is bushes. All right. So bushes. This is a Google Earth snapshot of where we've been working in Western Alaska. And you can see these are mountain ridges here. So the brown stuff is basically bare rock. The white stuff is snow fields or glaciers. This is a river out here. These things are lakes. And then this green stuff through here is vegetation of any sort and form, ranging from small little grasses to trees that are, I'd say, about as big as any tree you'd see in the Black Hills. I'm from the Pacific Northwest, so when I think of trees, I think of trees. But they're Alaskan trees. It's a pretty harsh environment out there, so the trees don't get that big. But a whole lot of this vegetation here is bushes. Okay, and this is what it looks like. Okay, so here's your ridge top that's barren, it's just rocks. And then all this stuff in between is bushes. And sometimes you can find a little trail that goes through and it's okay, but before you know it, you're completely surrounded by bushes and you don't know which way is up or how to get out of them. And you're lost and confused and grumpy. And being bitten by mosquitoes because there is a bunch of lakes right there. Right, so this is usually how we go about bushes, which is the, sort of offensive guard attack, where you just hands out front, assume the position and go for it. Try to push things out of the way so they don't push you out of the way. That works most of the time. You'll also notice here that there's no leaves on these bushes. This is another reason to do field work early in the summer, because as you go later in the summer, there's leaves on everything. It's just that much more biomass that's trying to keep you back from what you want to do. And it makes it harder to see through the bushes to figure out where you actually want to go, right? To find the next clearing to get through to. So here's a picture of one of my grad students, Brianna Murray. She's here in the bushes and she's not having a good time. She gets out of the bushes and I like this picture. I'm not sure. It's kind of like the Mona Lisa, where it's like you're not sure if she's smiling or if she's pissed off. So I'm not sure if she is happy that she got out of the bushes or if she has that look. It's just like, why are we doing this? You chose this trail, right? But so a funny story about bushes is actually just a couple of days before I took this picture, we were walking through some bushes and I'm visually impaired. I wear contacts most of the time, but when I'm out in the bush, I wear glasses. Okay, and so I was walking through the bush doing the, offensive lineman thing. And a branch comes around, grabs my glasses and flings them. And whoops. And, I've got, let's see if I can find the picture. I've got some hip glasses. They're like clear lenses, or definitely clear lenses, clear frames, right? Clear frames, gray, the color of a stick. Okay, so we're here in the bushes. My glasses have gone somewhere. And I can't see anything, right? And so it's like a scene from Scooby-Doo where Velma loses her glasses and she's on her hands and knees looking for her glasses, right? And so that was me. I was like, I can't find my glasses. And anyway, because they're, gray glasses surrounded by gray sticks. and I without my glasses, it's like right here is where I can see stuff. So I'm nose on the ground looking for my glasses. So I scream out, Brianna, help me. And she comes up, she finds my glasses. Brianna doesn't wear glasses. So she saved my butt that day, I guess. But I can't tell if she was grumpy with me this day or not. But anyway, so there's a story about bushes for you. Not all bushes are bad. So a perk of the bushes or working in the lower country is that there are blueberries everywhere, which is awesome. Yes, I was getting to that. Yeah, so it's great because you can just walk along, grab blueberries and snack as you go through. Actually, one year, a storm came in and we sat and we were running painfully low on food, but we had blueberries, so we ate blueberries before we could finally get out of the field. But yes, as somebody just said, where there are blueberries, there are bears. Right, so the blueberries, it's sort of a double-edged sword. They're yummy, they're tasty, In the fall, come August, they start to turn a really nice red color. It's really pretty. But that's when the bears want them too, because that's when they're really, really plump and ripe and tasty. All right, so I've come up with some new bees. And the first bee the first new bee anyway, is the Bering Breeze. Okay, so this is an alliteration. We've got a project now working in Western Alaska in this range here. In this area, they call it the Wood River Mountains. Over here, they call them the Alaskan Mountains. This is Wood River State Park, if you've ever heard of that, or the Togiak Wildlife Refuge. Up here is the Kuskokwim Wildlife Refuge. Just north of that is where the Yukon River goes to the Bering Sea. So Bering Sea is cold and big. Okay, so it creates a lot of water, or it creates a lot of weather, right? And that weather, where's it going to go? Right on land. Well, I'm sure a lot of you in this room know about the orographic effect. So if there's any topography and any weather coming and interacting with that topography, the mountains will push the weather up. When the weather goes up, it gets colder and it rains or snows. That's why we have intense weather here, is because of the Black Hills. The Black Hills are pushing up the weather that comes either from Hudson Bay or off of the Gulf of Mexico. All right, so not different here. The Wood River Mountains are the first topography off the Bering Sea. So where do you think it rains? The Wood River Mountains, right? So day one of field season 2023, it looked like this. This is from the helicopter window. So the helicopter bubble windows are kind of curve shaped like this. And you can see the rain just beating off of the sides. And the pilot, more than one occasion, said, I don't think we can get you over that mountain pass. I'm just going to drop you here. I'm like, okay, so he just dropped us here. So it's good to have a cautious pilot, but you don't always get to go where you want to go. So the Bering Breeze is a formidable foe. And in one case this summer, the pilot dropped us out at the Dillingham Airport. So Dillingham is a city right down here. And it's, basically a port town right off of Bristol Bay. And at the time, my hair was a lot longer and it never stood down. It was always off to the side like this, and it wasn't dry either. So the Bering Breeze is a formidable foe. A similar story from another field season in Alaska, another field site in Alaska. In this case, we were working in the rain shadow of Denali, which is formerly known as Mount McKinley. It's the tallest mountain in North America. It's about 20,000 feet tall. Okay, and so just like any other mountain, it makes its own weather, and it catches all the weather from everything else, pushes it up, and rains it down. Okay, so this was, I believe, June 1st, something like that. And it had been raining the day before. And I woke up this morning to this kind of scuffing, odd sound coming off of my tent. And, first thought is, it's a bear, right? That's always your first thought when you hear something weird. It wasn't a bear. I opened up my tent and it was snow that was sloughing off my tent and landing at the bottom. And so just made it hard to go see the rocks on this particular day, right? So a quick note about weather. I've shown you a lot of pictures of, nice-ish days. More often than not, it looks like this, where you're just sort of sitting right below the fog line. And for the most part, this is fine, right? It keeps the temperature down, you can still work. But when that fog comes down, this is actually a really big issue for geologic mapping, because you have no idea where you are. So you're out there with your map and you're like, oh, I'm right here and the rocks are this, and you make your map. But when you're inside of a cloud, you cannot map because you have no idea where you are. You start walking in some direction, you're looking at your compass and you're like, is this really north? Am I really walking north? And before you know it, you don't believe your compass, you're totally lost and you're stuck inside of a cloud that's raining on you at 37 degrees. So it's actually quite dangerous. It's perfect hypothermia conditions. So that's something else to think about. And of course, like I said earlier, the glaciers tend to make their own weather as well. So when you're up high working on these ridges, like I showed you earlier, got to be really paying close attention to the clouds and what they're doing as well. Because if you're on a ridge, fortunately, you can just go down the ridge. That's fine. But you got to know what to do once you get down the ridge too. All right, boots, another B here. Everything's wet. I hope that I've made that case to you effectively. So including your feet. And I go through a pair of boots just about every year, between the water damage and slicing them on rocks and all that kind of stuff. We've come up with a couple of approaches over the years on ways to try to keep your boots dry. It doesn't always work that great. So this is a friend of mine, Tyler, who came with me to the field one year. And this day we were working pretty close to camp, and we decided, you know what, I really don't want to walk across the creek and get the cold water inside my boots again, just like we did yesterday and the day before that. So we took our rubber boots with us, our knee-high rubber boots, and we crossed the creek in those, put them back in our backpack, put our dry boots back on, and it worked okay, but it's not really practical to do it every day. But man, be prepared to have wet boots. Okay, so last B I'll talk about, beautiful. Okay, I hope I've convinced you that the things I do are worth doing. It's also really difficult to do this. Occasionally, the sun comes out and you see something that looks like this, and I always say to myself, I'm at work right now. This is way cool. All right, so this is a picture of, there's all these awful names that I can't ever pronounce. So Chukumanuk Lake, this is in western Wood River Mountains. Just a wonderful, beautiful spot to do work. Even if the clouds come down a little bit, still an absolutely beautiful place to be. This is the Alaska Range from Midway Lakes. This is over by the Alaska-Canada border. So the big mountains out here in the Alaska Range is where I've done quite a bit of work when I was a grad student. This is a spot that I was camped out in 2019, where you can see some of the big mountains out here, and then there's really big mountains off the screen to the right here. And this was a really nice place to camp for a while. Turns out that summer there were really bad forest fires in Fairbanks, and Anchorage had, what was it, 3 or 5 days where they had temperatures above 90 in Anchorage, which is on the coast. So do you think people in Anchorage have AC units? No, they don't. And we certainly didn't have any installed in our tents either. So it was a pretty toasty couple of weeks sitting out there in 90 degrees, breathing smoke, and there's no way to get out of it. So I just sat in the creek, and top half of my body was hot, bottom half of my body was ice cold. But it was better than everything being hot. So anyway, I took this picture late in the night, I don't know, 10 p.m. or something like that. Kind of neat. You can see the red sun and all the smoke. So it's definitely a neat experience, but not all that fun in the moment. So with that, I'll stop there. I'd just like to say thanks for coming tonight. And Sarah Ruskey, my graduate advisor, got me started working in Alaska. And if I can help it, I won't stop, because it's fun and there's a lot of job security mapping up there. So I hope you've learned tonight. And then my grad students, Jillian Clark and Brianna Murray, took a lot of the pictures that you saw today, along with Sarah took quite a few of the pictures as well. So with that, I hope you learned something, and I appreciate you being here, and I'm happy to answer any questions that you might have.
Any scary moments with helicopters or planes?
Oh, scary moments with helicopters or planes. I will say the first time I rode in a helicopter, I was really freaked out. It was just so bizarre, such a bizarre feeling. To my recollection, actually, yes. In the plane, so that red plane I showed you earlier. Times like this, you realize how many slides you have. So this plane here, and this was 2016. So the day that we flew out of there was one of those times when you call the pilot, can you come get us? Nope, not yet. And can you come get us? Nope, not yet. So we sat there for, I think, 5 days, having that phone call on the sat phone every day, and eating blueberries because we ran out of oatmeal, and reading books. You get to a point where you're like playing poker with your books, because you're like, oh, I'll trade you this one for that one, because you read all the books that you brought. And so anyway, we got out of there finally, and there's a wind gap in the mountains. Let's see here. Yes, this one here. So that field site is right here. It's this circle, and there's 2 wind gaps through the Alaska Range. One of them is over here, And then the other one is over here. And I've done a lot of work right in here where that other wind gap is. And so where we were, the air was pretty still. But as soon as you get into that spot, it's like a funnel in the mountains where all of the weather basically coming off the North Pacific, funneling up through here, and then going into interior Alaska through here. All of that weather is just getting funneled into that wind gap. And that's where do you think we flew through, right? So he had to fly into that to come get us. That's why he kept telling us no, because he's like, there's no way I can fly through that. And on our way out, we were flying through there going, what do you say, something like 130 knots or something like that, because we just had this tailwind. And that's not the scary part. The scary part is there's an Air Force base right over here. And they were doing something that he either didn't hear or they weren't talking about on the radio. And this F-15 just goes right in front of us. And aside from seeing it, like that was scary enough, but the wind off of it too, because we were already just riding this tailwind, and then that thing came in and hit us from the side. And that's probably my scariest airplane story. Yeah. I will say, this last summer, just after we got out of the field out here, and we had some bad weather days, definitely, the State Geologic Survey was doing some work up here in Barrow, and they had a helicopter accident and everyone died on board. So 4 geologists for the state survey, and that was, I think, the week after we got out of the field. So that was a little survivor guilt moment there. It felt kind of weird, but personally, no, not too many scary helicopter moments, and I want to keep it that way. Yeah. So, any other questions? Yeah.
So obviously, the pack minimally, but you don't catch the salmon.
Oh, that's a great question. Yeah. So my grandpa for years was saying, well, bring your fishing pole. and the reasons I always said, no, I'm not going to do that, is because most of the places historically where I've worked are where the glaciers are, and there's just not really running water. And it's also early enough in the season that the salmon aren't that far upstream yet. Yeah. I will say though, let's see here. This last summer, when the helicopter pilot brought us our little bug net coat thing, we were at, let's see here, we were at one of these field sites, this field site here. Their mechanic had gone salmon fishing the day before out in the bay, and he brought us some fresh fillets. So that was by far the best food I've ever eaten in Alaska, in the bush in Alaska. And it's a double-edged sword. So you eat a beautiful red, yummy salmon fillet. Oh, that was so tasty. And now you have this bag of salmon skin that's just sitting in your kitchen tent, right? And it's like, that is the stinkiest, most attractive garbage this side of the Yukon River. And so there's just like this amount of paranoia that comes with something like that too. So that's another reason that I've never been too eager to go and fish while I'm up there, is because, yeah, it'd be great to have the fish, but then you also have to. I'm not the largest. I'm not the top of the food web. Yeah. So yeah, it's certainly appealing sometimes though. Yeah. Or when a ground squirrel keeps raiding your Cliff Bars day in and day out, and you start looking at your gun and you're like, so anything else?
I have a question.
Yeah.
Do you have any idea or guess how many other geologists like yourself are doing projects like yours, trying to map the Alaskan wilderness?
Very few. Yeah, compared to folks working in the Rocky Mountains, very few. So let's see here. It's always tricky with Alaska, because any map that you see with Alaska and Hawaii on it, along with the contiguous 48, Alaska and Hawaii are always at the wrong scale. Hawaii is made bigger and Alaska is made smaller. But a ballpark estimate is that mainland Alaska here, so not the Aleutian Peninsula and not Southeast, is about the size of the Rocky Mountain West. Okay, so basically California to Colorado-ish, ballpark, okay? And there are a couple folks in like Stanford and West Virginia, New Mexico State that work up in here in the Brooks Range. So those are faculty, and they've all got some grad students. My advisor has been working a lot here in the Alaska Range, and then down here along the coast, and she's had some grad students. And then it's me, and I've got a couple colleagues in Fairbanks, and we work on projects together. But I mean, if you were to count all of the academics and their grad students that are continuing on to do this work, I'd say fewer than 20 people. Yeah. 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 So I might kick that one over to Colin, but there are a lot of mining companies that either have active mines in Alaska or prospects, or they're doing exploration or something like that. And they typically hire their own geologists to do the work for them. So academics like myself, we typically don't get hired by mineral resource companies to work on their projects, but I have hitched a ride in a helicopter from one of them. So in that way, it was a little under the table funding from them. But I don't know, what's your experience been, Colin? Similar?
Mining companies locally would be doing mapping projects.
Yeah.
Yeah. What about the USGS? Are they?
Yeah, so the survey has recently had a pretty large project in this area here in interior Alaska, and there's a lot of gold mining, gold mineralization in that area, and so they're mainly focused on that. But the thing with the survey mapping projects is it's all about resources or hazards. You know, this map that I showed you here, the USGS mapped, quote, all of Alaska between the 50s and the early 80s. And, you know, it was basically right after Alaska became a state, and they were like, well, we need to know what's out there so we can know if we need to, where to build roads, why to build roads, all that kind of stuff. So they had a big push to map all this stuff at 1 to 250,000 scale, mostly in the 70s and 80s, but some got an early start in the 1950s. And then that has been it. So any follow-up mapping or fixing problems like this is all nowadays completely related to hazards or resources. So if there is a big gold mine right there, then they would go in and fix this. But there's not, it's at least based on the pre-existing mapping, there's no reason for them to go in there and do that. And so the way my approach to this stuff is and has always been interesting science questions. So like, how do faults work? How does the crust form? Why are the mountains where they are? And when I can get those types of things funded, then we can go and do the mapping that's hyper specific to the thing that we need to do. And, you know, sometimes that means we go out here. Sometimes that means we go here. I haven't yet found a reason to go out here, but I'd love to. It's actually a huge graphite deposit out here. So the survey has been working out there on that. But again, that's all. What's that? Yeah, exactly. So, but survey money is public money, right? They're funded by the federal government or state government. So it's, yeah, not a lot of private money, but if you know somebody, I've got open pockets. Yeah. Anyone else?
I have another one. What scale do you use when you're mapping?
I typically use 1 to 10,000. And that's partly because it's a number that I can process in my brain. But also for the types of things that I like to do and the reasons that I go mapping, it's a scale that makes sense. You know, I usually don't need things to be higher resolution than that. Sometimes I'll do 1 to 20 or 1 to 24K, K being 1,000, 1 to 24,000. If it's sort of a regional quick, I just got to walk through and see what's here type of a map. But if I'm going to sit somewhere for a while and map a radius around my camp, it's 1 to 10,000. And then, you know, when I go and publish a map, wherever that one is, oh no, it's way out there. So when I go and publish a map like that colorful one that I showed you here, this is not at 1 to 10,000. This is at, well, here's the tricky thing with ratio map scales is if you zoom in, all these are digital, right? So if you zoom in, you change the map scale. So there's actually no reason to put a ratio map scale on this, but well, I guess I did. Oops. So I usually just put a bar like this, but I guess here I put 1 to 55,000. So I'll map it 1 to 10, and then when I publish it, it'll be a lot coarser resolution. And so a lot of that's just out of necessity, what I need to actually do for that particular publication. Yeah. But then I have the higher resolution maps if I ever want to do something with them. Yeah. So yeah.
It's 10 years or more are gonna bring forward this.
Yeah. Well, so next 10 years, that's tricky. Yeah. Well, so there a lot of things have just happened just now, and probably the biggest advance is not so much scientific, but more in terms of safety. So when I started doing this stuff, it was sat phones. And if you're working on the north side of a mountain range, a sat phone is not your friend because you'll get a call and then the call drops. And if it's an emergency, it's not going to work out very good. Back when they were doing this stuff in the 70s and 80s, it was just radios. They just radioed out to their team who was in the field. Now we have these Garmin InReach devices, which are basically a GPS that you can text from. And when you send a text to somebody, it tells them your coordinates, and it's got an SOS button on it that alerts the National Guard and all that kind of stuff. So like safety advances in the last 10 years have been huge. As far as technological advances, if you zoomed in on this map, it would be incredibly pixelated. So we actually haven't historically had a very good understanding of what the topography of most of Alaska's mountain ranges even looks like. And I think in 2015, there was a satellite radar mission where they did a bunch of satellite scans across Alaska. And there's some high resolution data in here. And then I forget where else, maybe up in here. Then now we have 5-meter resolution on the topography. So that's been pretty good. And that's actually that map I showed you earlier with my field map, that's made out of that 5-meter resolution topography. But then there was another big project just recently that was a polar program project where they again did the satellite imagery of everywhere in the poles. And now we have 2-meter resolution on the topography all over Alaska and all over Canada and Greenland and everywhere north of 60 degrees. We have 2-meter resolution topographic imagery. And so we can use that to make contour maps. It's satellite imagery. We can look at the vegetation maps and all that kind of stuff. So that has been a really, really big breakthrough. Another thing that's happening is I'm a little bit old school. I use paper maps still. And part of the reason I use paper maps is because I don't have to charge them. But digital mapping with tablets and iPads is becoming standard. And this last summer actually was the first time I ever played around with that in Alaska. And so, you know, you got to get a waterproof case for your iPad and all that stuff. And if the sun comes out, when the sun comes out, that's kind of a difficult thing because, well, it's a sunny day. You want to use it to go do stuff. But it's also the day that you can use your solar panel to charge your iPad. So it's like you can charge a battery pack and then charge it at night. That works okay. But when the vast majority of your days are overcast at best, relying on electronics and solar panels is not great. So anyway, if there are ways to advance those technologies, I think those will become more common in Alaska. But a lot of people do what I do, where we just print out paper and then put Mylar on it, which is basically a poor man's laminate. And so we laminate our field maps with tape and Mylar, and then we can draw on them and they don't get too wet. They still get kind of wet, but yeah, so that's one. Yeah.
Official vegetation to track of contact boundary, or is it just too dense to be able to specific type of vegetation or flora?
Well, I'm probably the farthest thing from botanists in this room, but in my experience, the vegetation has not been that good for tracking rock types, with the exception of ultramafic rocks, because not that many things grow on them. They don't like chromium. Yeah, but by and large, most of the low areas are actually not primary rock types, it's glacial till. And so it's soils developed in till, and that's the substrate for most of those bushes that I was showing you. The ridges where it's actually the rock types, there's not a lot of vegetation to start with. Yeah, yeah. I saw another question back here, yeah.
Kind of more of a story side, but and you probably won't discuss the eclipse, but in 90 seconds or less, characterize the geology of the area. Didn't live there already.
In which mountain range? In Western Alaska. The Wood River Range. The Wood River Range, yes. All right, so let's see. I'm gonna take you to the topographic map, and we'll just have to use our mind's eye to look at the geology there. Is that it? I guess, oh wait, no, the Bering Sea map. That's what we need. Here, okay. So do you see this line running right through here? There's a big lake there, and the line runs out there. That is one of the biggest faults in Western North America. It's called the Denali Fault. It's a right lateral strike slip fault. So what that means here is that if we hold this part stationary, this part here is going out to sea. Okay. So that's a big fault. Over here, we have a couple of volcanic island chains. Think Japan. Those collided with North America. We actually don't know the ages very well, but let's just say 200 million years ago. Okay. Down over here, we have another one of those island chains that collided with North America about 140 million years ago. Okay, so I don't know what I'm doing for time right now, but basically what we're looking at is a couple of island chains that have collided with North America, and they're being now sliced through by a big fault that's moving things sideways. Yeah, another way to think, yeah, Japan, Sumatra, the Aleutians, the Lesser Antilles, like Bahamas area, think something like that. So a good analogy that, and this is from a paper from like 1960 when we were just learning about plate tectonics, but a good analogy is that 200 million years ago, Western North America offshore had all these island chains, and it basically looked like the South Pacific does right now. So this is a really cool paper where actually they had Western North America with all these islands, and then they took a picture of Australia and turned it on its side, and then had all the islands north of Australia. So if you rotate Australia around so that the islands are off the west coast, which would be the north coast of Australia, and then Australia basically would move to the west and then just scoop up these islands as it's moving to the west. And that's basically what the geology is for all of Western North America, from basically the crest of the Sierra Nevada all the way up through Canada and off into Alaska. Actually, only a very small part of Alaska is truly North American rocks. Yeah. Anyone else? All right. Thanks, everybody.
I just want to real quick, thank everybody for coming in. We do this every third Tuesday. So next month, the date is December 19th. And our speaker is Josh Wilhite, who is the project manager for the Long Baseline Neutrino Facility at SURF. It's the cavern that's currently being excavated for the Dune project. So he's going to talk to us all about that and give us an update and show us some cool pictures. So hope to see you then.